students, today we are going to study about the preparation of benzene, its physical properties as well as its chemical properties. Okay, so moving on to the preparation of benzene. Okay, how can we prepare it? First method, we can see that he has 3 molecules of ethyne taken in a red hot iron tube. Okay, it means temperature is high, so temperature taken is 873 Kelvin, we get benzene. Actually here we are seeing that he has how many molecules of ethyne has been taken. It is 3 molecules of ethyne. Okay, what does it do? It aromatizes, okay, to form benzene. So this is basically what aromatization reaction. Now we are taking sodium benzoate, okay, and we are adding NaOH to it with the presence of calcium oxide and heating it. We are getting benzene and sodium carbonate is released out. So this is basically which reaction? If Na2CO3 is being released out, it is a decarboxylation reaction. Okay, now taking phenol, okay, in the presence of zinc dust, we are heating it. We are getting what? Benzene plus ZNO. So what has been, which reaction has been taken place? Actually here reduction has been taken place. Oxygen has been removed. Okay, now coming to the physical properties of this benzene. Okay, it is a colorless liquid with a pleasant smell. Okay, and yes, if we talk about its solubility in water, okay, it is insoluble in water. Why? Because this is a non-polar compound. Okay, it is basically soluble in non-polar solvents, not a polar solvent. Water is a polar solvent, isn't it? So as the result, it is insoluble in water. Okay, it is toxic also is nature because it is poisonous. Okay, and when we say that which is lighter, water or benzene, it is water is heavier than benzene. So what happens? This benzene is lighter than water, so if you keep it in a glass, okay, you can see the separation level also. You can see that yes, benzene gets arranged at above water, so it is lighter than water. Okay, as this is an unsaturated hydrocarbon, okay, so it will burn with a sooty flame. Okay, its boiling point, when we talk, it is 80 degrees Celsius and the melting point is 5.5 degrees Celsius. So now let us study about the chemical properties of benzene. Okay, the first is the reaction which it shows is the electrophilic substitution reaction. Okay, in this we'll be seeing that yes, the electrophile attaches and the reaction, in the reaction what substitution is taking place. Okay, so first reaction is the nitration reaction. In this benzene, okay, this benzene reacts with what? HNO3 plus H2SO4, okay, and it gives what? Nitrobenzene. It gives nitrobenzene plus what? H2SO4. Okay, so how this reaction has taken place? Actually, let us see. First of all, this HNO3 and H2SO4, okay, it reacts and it generates an electrophile, that is NO2 plus, and what is released? H2O and HSO4 minus. Okay, now as soon as this electrophile is generated, okay, this electrophile attacks this benzene, okay, and it gets attached to it, forming a intermediate. Okay, and yes, this is the property of benzene, that yes, it takes up the electrophile. Okay, and as the result, this NO2 gets attached to this benzene ring, creating a intermediate. Okay, now as soon as this intermediate is formed, you can see that when NO2 is attached to benzene, okay, this plus sign shifts over here. Okay, this intermediate which has been formed, now what does it do? It takes up the HSO4 minus present in the reaction. Okay, and here now in this you can see the electrophile has been attached. In this we will be seeing this hydrogen is being removed, substituted, this NO2 has substituted this hydrogen, okay, thereby forming what? Nitrobenzene. And yes, what is released out? H2SO4, because this H has been released out from here, it has been substituted, thereby forming what? H2SO4. This is how the reaction of nitration goes on, and this is a electrophilic substitution reaction. Why it is an electrophilic substitution reaction? The electrophile has substituted this hydrogen, thereby forming a compound known as nitrobenzene. Okay. Now coming to halogenation reaction beta. When I say about halogenation reaction, it is also an electrophilic substitution reaction, okay, of benzene, and here we will be seeing what? The halogen will be attached to the benzene ring. So now let us see the reaction. The whole reaction is what? We will be taking benzene, okay. We are taking benzene, okay, plus we are adding Cl2, plus we are adding AlCl3, okay. So now the reaction goes on, and what is being formed? Benzyl chloride, isn't it? Benzyl chloride is formed, plus you will be getting AlCl3 plus HCl. Okay, so now how this reaction has propagated, let us see. Okay, so first of all, this Cl2 and AlCl3, okay, reaction between them, and the electrophile is generated, that is Cl plus, okay, plus we are also getting AlCl4 minus, okay. So now as soon as this electrophile has been generated, what happens? It attacks benzene, and as benzene shows electrophilic substitution reaction, it has the affinity for the electrophile. What happens? This chlorine attaches with this benzene, and here you can see as soon as it gets attached to this, the plus sign shifts over here. Okay. Now here the intermediate has been formed. Okay. This intermediate taking up this AlCl4 minus. Okay. What happened? Now substitutes this hydrogen, thereby forming what? Benzyl chloride. Okay. AlCl3, and this H has been substituted from here, attaches with the chlorine to form the compound, this HCl. Okay. Now coming to sulfonation reaction. When I am saying sulfonation reaction, it means here H2SO4 will come, and yes, sulfonic acid will be attached to benzene ring. How come? See, we have taken benzene, okay, and we have taken concentrated H2SO4, 98% concentration should be there, because it should be a fuming one, okay. So here concentration of H2SO4 must be 98%, okay. Heating it, what happens here? It substitutes the hydrogen over here and forms what? Benzene sulfonic acid, and yes, with the hydrogen which has been substituted from here, okay, combines with this H and one oxygen to form water. Now moving up with the next electrophilic substitution reaction, that is Friedel-Crafts reaction. Okay, in this benzene reacts with methyl chloride in the presence of anhydrous aluminum trichloride to form water, this toluene plus HCl. Okay, how the reaction moves on then? See, this CH3Cl, okay, reacts with this AlCl3 which we have taken, okay, and it generates the electrophile, that is CH3 plus AlCl4 minus is formed. Okay, so now this, as this electrophile has been generated, and this benzene has the shows this electrophilic substitution reaction, has the affinity for this electrophile, what will happen over here? This benzene, okay, here naturally it will react with this CH3 plus, okay, and thereby it will be forming a intermediate, okay. Okay, and the plus sign will be shifting over here. Now this intermediate, okay, see what happens over here. Okay, it takes up this AlCl4. Okay, and as the result, now what will happen, this H will be substituted. Okay, so it will be thereby forming what? Toluene. Okay, toluene has been formed. Now this H has been substituted. Okay, this H along with the Cl forms HCl, and thus this plus sign also is removed after the substitution, and thereby forming what? Toluene. So this is Friedel-Crafts reaction. Okay, now coming to Friedel-Crafts acylation reaction. Acylation reaction means we will be taking acetyl chloride. Okay, so now here what happens, benzene in the presence of this acetyl chloride, okay, and anhydrous aluminum chloride, okay, heating it, we will be getting acetophenone plus HCl. This is also a electrophilic substitution reaction. Okay, actually this CH3 COCl, okay, plus this AlCl3, they will react to generate the electrophile, that is COCH3 plus, okay, and plus what will be formed, as earlier we have seen, AlCl4 minus. Okay, now this again it will be here, it has the affinity for the electrophile. This electrophile will be attached to the benzene ring, thereby forming what? Intermediate again, and this intermediate, okay, again reacting with this AlCl4, it will be forming what? Acetophenone, okay, and plus the H which has been substituted, taking one chlorine from here, forming what? HCl. So this is what also electrophilic substitution reaction. Here, due to this electrophile, this hydrogen has been substituted from the benzene ring. So benzene also shows addition reaction. Okay, number of addition reactions we see in case of benzene. Okay, so first addition of hydrogen, let us see. Okay, so benzene, if we add hydrogen to it, hydrogenation is taking place, isn't it? In the presence of a catalyst, that is nickel, and yes, we heat it. And yes, if hydrogenation is taking place, okay, here 6 hydrogen is being added to benzene. So naturally now what will happen, these double bonds will break, and this hydrogen will be added to this ring, thereby forming what? Cyclohexane. Okay, now if we add chlorine, okay, and it depends, okay, if we add only 3 molecules of chlorine, okay, to benzene in the presence of ultraviolet rays, temperature also 500 Kelvin, you should take in mind that. Okay, so here also you will be seeing this chlorine will be added to this benzene. How it will be added to this benzene? Here this double bonds will break and this chlorine will be attached to the carbon, thereby you will be seeing over here they form what? Total single bonded compound, that is what? Benzene hexachloride, and commonly we say it, or we write it as BHC, okay, and commonly we call it as gamaxane. Okay, if we add now, okay, how much? 6Cl2. Here the number of molecules of chlorine has been increased, it is 6Cl2. Initially we had taken 3Cl2, okay, now we are taking 6Cl2, and yes, conditions are that we are taking anhydrous AlCl3, and it is in dark condition, okay, as well as cold condition is there. What will happen? We'll be seeing that here Cl2 will be joined to this, chlorine will be joined to this, okay, how, in which manner? Let us see. Here you'll be seeing chlorine so it is replacing what? The hydrogen. So naturally here 6 chlorine attached to the benzene ring by replacing the hydrogen atoms. So this hydrogen atoms, another 6 chlorine, it will be added to form what? 6HCl. Okay, so just keep in mind the reaction with chlorine okay, when benzene reacts with chlorine, when it reacts with 3Cl2, okay, ultraviolet 500 Kelvin, we get what? Gamexane, or we can say commonly as benzene hexachloride, okay, or BHC also we can write, okay. Here what happens when it reacts with 6Cl2, in anhydrous AlCl3 is used, in dark and cold condition we get this hexachlorobenzene, okay, and 6HCl is given out, okay. Now coming to combustion reaction, okay. So combustion reaction, in which we are saying, if we are saying combustion reaction, it means what? There will be the presence of oxygen, okay. So benzene will be burned in the presence of oxygen, and how much oxygen we will be taking? 15 upon 2 it, or 7.5. We will be getting what? Carbon dioxide plus water, okay. This is benzene, so you will be getting 6 CO2 plus 3 H2. Now let us study the directive influence of the functional group in the mono-substituted benzene, okay. So mono-substituted benzene, we have to take here one hydrogen in the benzene ring has been substituted by OH group. That this is now which phenol group? It is mono-substituted benzene, okay. Now if further substitutions are there, there are three possible distributions, okay, and that are not equal. What are those three possible distributions? Ortho, meta and para, okay. Now two types of behavior is shown in this, and that is the ortho, para and the meta, okay. So when it is reacting with the other substituent, okay, further substituents are being added to this phenol, what happened? Here we'll be seeing the product which is being formed does not depend upon the other substituents which are being added. It is depending upon this mono-substituted benzene, okay, the substituent which has been attached with the benzene, okay, and thereby here the directive influence of the substituents are shown, okay, by the nature of the mono-substituted benzene, the functional group which is present over there, okay. So I said to you that yes, two types of behavior it is showing, that is the ortho, para and meta. Let us take the example of the ortho, para, okay, directing group. For that I have taken the example of phenol, okay. Here we see that the movement of electron starts from the OH group, and yes, we see in the second step that yes, the density of the electrons increases in the ortho position, and then we see it at the para position, and then again in the ortho position, okay. So completely what is going on over here? Resonance is going on, isn't it? Here as it is ortho, para directing, we are seeing the electrons are directed towards the ortho and the para position. The electron density in the ortho and the para position increases. But yes beta, this is OH group, and yes, we have studied in this what is this OH group has got minus I effect, and yes, if it has got minus I effect, naturally it should draw electrons from the benzene ring towards itself, okay. And yes, if it is taking the electrons from the benzene towards itself, if the direction of the electrons is from the benzene ring towards this OH group, okay, what will happen? The electron density in the ortho and the para position should decrease, isn't it? But no, here dominance is shown by the resonance, okay, and this is why we see that yes, it is ortho, para directing in nature, okay. If it was showing only minus I effect, here electrons should be moving from benzene towards the OH, but as here it is showing resonance, okay, which is dominating, and thereby we are seeing the increase of electrons in the ortho, para position. Now this OH group, what does it do? Actually this OH group activates the benzene ring for the attack of an electrophile like amides and amines and others also, okay. So basically for the attaching of the electrophile, it activates the benzene ring. Okay, so here if we see this chlorobenzene, okay, in this what happens, this when we are seeing this mono substituted position, here H has been substituted by which? Chlorine. Okay, and yes, we all know this chlorine has got what? 2 electronegative value, isn't it? So it will be showing a minus I effect. It will be withdrawing the electrons from the benzene ring towards the chlorine, isn't it? And thereby making the further substitution difficult, isn't it? So what happens? But we don't see this. We see that yes, here also the density increases at the ortho and the para position. When we go on, see the resonance structure of this chlorobenzene, we are seeing that yes, electron density is increasing at the ortho and the para position. Okay, so here if the electrons are increasing in the ortho position and para position, it means here the electrons are being what? Moving from this chlorine towards the benzene ring. And here also this happens just because of the resonance. Okay, this resonance, which is what? Which is bringing the ortho para directing positions. Okay, even though this is 2 electronegative in nature, okay, it shows its effect. Substitution becomes difficult, but yes, again this due to this resonance, it shows what? Ortho para directing group. Now let us study about the meta-directing group. Okay, here I have taken an example of what? Nitrobenzene. Okay, so here nitrobenzene NO2 is being attached to this benzene ring. One H has been substituted by this nitro group. Okay, so this is also a mono substituted benzene. Okay, so here we see what? In this, here the electron density in this ortho position is less. It is positively charged. Here in para position, again positively charged. Totally electron density decreased. Okay, but yes, in this meta position we don't see it, isn't it? So comparative to the ortho para position, where we have seen that yes, electron density is at ortho position and the para position, as the result the electrophile, the attacking electrophile gets attached to the ortho or the para position. But here we are seeing that it is positively charged. Okay, this ortho and para position is positively charged. Naturally, it is electrophile will not have the affinity to get attached to this position, isn't it? So what is happening over here actually? This nitro group here, this decreases the electron density at ortho and para position. Okay, why does it do? Because this is a strong, it shows strong minus I effect. We have seen of this alcohol group, we have seen of this chloro group. Okay, in that also they were showing minus I effect, but yes, the resonance effect was dominating. But here it is also showing very, very strong minus I effect, and thereby it is deactivating this group totally. And now we are seeing that yes, here in ortho and para position it is the positively charged, rather than the electron density totally decreases. Here resonance is not dominating over the minus I effect of this nitro group. So as here positive electron density is less, positive charge is there at the ortho and the para position, the electrophile will not be able to go and attach over here. It will not have the affinity for the ortho and para position. But as we comparatively see the meta position, here we are not seeing too less density of electron, positive charge is not there. So what happens? This electrophile will go over here where there is at least some electron density over there, and it will be attached at the meta position. Okay, so this is all for today. Okay beta, hope you might have understood it. Good day, take care.